Hey, how's it going, everyone? Today I'm going to be doing additional tests on the DC resistance of wires. I did get a new meter, so this time it'll actually be the DC resistance that I'm able to measure. And I set up a way to make it easier to test. I have some GIMS distro blocks, and I'm just going to run the wires from the distro blocks that I have set up to each other and use the new meter to get much more accurate results on the DC resistance of the different types of wires. So I'm going to be retesting everything that I had tested previously, as well as a few new kinds of wire I got. Yeah, I saw some like 4O aluminum wire. I've never really seen that before. I'm probably going to test some 4O copper wire and just add in a whole bunch more wire types to the test to see really how they all compare and be able to get some concrete numbers on what this will do to your voltage at different levels and different lengths of wire. So without any further delay, I'm going to go ahead and get started. I will explain the resistance meter in the next shot.
Okay, so what I have here is a VC 480C+. This is it's a dual wire tester, so it has separate sense and current wires, and it allows you to negate the resistance of the actual leads itself. So I'm going to turn this on to 20 milliohms. And then I'm going to hook these up together, that way I can zero out the resistance and make sure that these wires are not included. So just hook them up to each other, and then I want to get this zeroed out. Okay, so now that we have this calibrated, we will go ahead and hook these up to the different spots on the terminal. I'm going to leave these hooked up the entire time. I did secure these, so that wouldn't be a problem. And then just plug the wires into this terminal and this terminal respectively. That way we can get a measurement on the wires. So again, starting out, this first bunch of wires is all going to be 48 inches. Okay, first up, we're going to be doing, I don't know if you can see this in the camera, but we're using down for sound wire. This is labeled their Superflex line. It is 48 inches. It's 100% oxygen-free copper, but it actually, while it says it's OFC, it looks like it's tinned as well because the wiring is tinned clearly. So. Okay, so as far as the down for sound 48 inches, we have a DC IR of, it looks like, we'll call that 0.64. It seems to have leveled out there. I'm going to take these off. And get the next kind of wire to test.
I actually guess I can just leave these hooked up. That shouldn't be a problem there. Okay, and next I have, this will be down for sound wire. 10, this is oversized car audio. It is 5,418.12 millimeter strands. Again, Same with 48 inches of this to measure the resistance that we get. Okay, so this is the Sky High car audio, and it looks like we've leveled out at about 0.57. Next up we have Windy Nation 1-0 welding cable, OFC, 48 inches. Okay, so we got this done, and now we're going to hook up the other input and measure the resistance. Okay, so 1-0 welding cable. We are sitting at approximately, it looks like, 0.76. So that's actually a pretty big difference. That's like 0.2 of a milliohm between the welding wire and the car audio wire that we just tried. So the next up, I have New Concepts Colossal Flex Tinned OFC wire. Again, this is like overstuffed car audio along the same lines as the Sky High car audio. So 1-0, this is 48 inches. Getting it hooked up now. I just want to make sure I'm getting all of the strands in, because even a few strands can, modify a reading, and I want to make sure that all of these have an equal chance to really be tested. We got to make sure that all of it's in there to be fair, and then get it securely crimped down. Make sure to get them all in there. Okay, it looks like 0.56. Next up, I have EB Flex 1-0. This is welding wire similar to the Windy Nation wire. It is not tin, but it is copper. So okay, so we have this. Now, get this side input and tighten down. Okay, it looks like bouncing between 0.67 and 0.68, and it stopped pretty well at 0.67, so. Next we have 2.0, and this is a bit of, it's moving up a step in wire, but being that this wiring costs less than, say car audio cable from Sky High, you can get 2.0 welding wire for quite a bit less. This is a lot of the wiring that I use in my personal vehicle just because it's such a good deal for pure copper. Instead of 1.0, you can use 2.0 of welding wire. And so here is the 2.0 wire that I have, and we will check the resistance now. It's definitely a tight fit into these 1.0 terminals, but with welding wire you can generally use one size larger. So for like 1.0 car audio wire, it's generally approximately the same thickness as 2.0 welding wire as far as the actual size of the wiring itself. Okay, so with 2.0 welding wire, it looks like we have about 0.5. One of our shop neighbors started an air compressor or something, so it got kind of loud. Okay, so now, just for good measure, I have some new concepts. 1.0, and it is their copper-clad aluminum. It is, let me see if it has the actual word in. It's the basic power cable. So again, 48 inches of this. And this is aluminum again. So, same length, 1.0 gauge, aluminum, not copper. Okay, so as far as the copper-clad aluminum cable, it looks like .95. Okay, so that was all of them that we tested last time. I will get this updated and graphed out, and we will test a couple new kinds of wire in a few minutes. Okay, so next up, I found this, that was pretty interesting, and it was a relatively affordable. It's Sky High Car Audio. It's 4.0 aluminum wire. Now there's a caveat here, since these are not, these won't accept 4.0. It'd be far too big, and I don't want to trim a bunch of strands. I will be using a reducer, 40210, and so that's something to keep in mind. But it's also a hurdle that you may face if you're choosing to use wire this big. Most distribution blocks, unless you get one that has lugs, aren't going to really allow for 1.0 inputs. So this will be with reducers. I'm not sure how much exactly that adds, but we will know the total soon.
Okay, I have the reducers now on both sides of the wire. You can see here. Okay, so with 40cc, I'm getting about 0.78. That's actually fairly close to the 1.0 of the welding wire. It looks like 0.77 is dropped too. So using 40cca is still not as good as using 1.0 copper, and especially nowhere near as good as using 2.0cca. I'm going to do my due diligence and just to make sure that these lugs are really tight and measure that again. Just to make sure that we don't have external influences like a poor connection affecting anything. Okay, so that one is tight. Okay, so yeah, they're both very, very tight. So, but just for good measure, here is the 40cca again. What I should do, keep things unified. I'm going to actually go with this side first. Yeah. Okay, 0.78. Okay, so now for good measure. I see people do this a lot, and I don't think that they think it matters, so I'm going to get a new base reading. I'm just going to use the copper-clad aluminum wire because it's the cheapest for this experiment. Go ahead and get that reinserted in this terminal so we can get a fresh reading just to make sure that we're being as accurate as we can here. So we measured it at 0.95 last time. Looks like we're about 0.96. Interesting, because it's normally pretty accurate. Okay, so we're back to the 0.95. We're getting consistent readings, that's good. And now what I'm gonna do is I'm gonna be careless, and do what I see many, many people doing. And that is, they're not even careful with this. So, I mean, you'll see them cut the insulation off. And it's not uncommon that they end up just using scissors and cutting through a whole bunch of the wiring here. So we're gonna reduce this wiring a bit by taking some of these strands off. A careless cut into it, and see then, once we jam that in, if it impacted the resistance much, if it impacted at all. So basically we've kind of reduced our own wiring here with a careless cut, just on one side even. And we're going to see what the resistance measures now. Make sure I
still get this tightened down. It has to be quite a bit tighter. Okay, so we've added about, it's bouncing between 0.97 and 0.98, but that is, that's a big increase when you're talking, that's for 4 feet of wire, and just that connection increased it like almost 2% resistance. So we had about 0.02 milliohms from a careless cut. This is much more detrimental with smaller wiring when it leaves even less, and it's a larger percentage that you cut off. But I mean, overall, that surprised me. That didn't hurt it as much as I thought, because I cut off a pretty good chunk. If you can see here. I'm not sure if it's going to focus right, but I mean, I cut off a solid chunk. So we did measure 2 milliohms of increase, but that's less than I thought it was going to be. But definitely still a measurable amount. And if you're wiring it up and have those connections everywhere, like if I had one on the other side, that's another 0.02 milliohm increase. And it just adds up if it's on every single connection. So you definitely want to, when you're cutting your wire, make sure it's more like this, and you're not cutting away all of the external strands of it.